Hi, welcome back to Moose in Chemistry. This is SI Unit Scientific Notation Problem Set Lesson 2. Okay, in this thing we're going to do a couple different types of scientific notation problems. Alright, so let's work this here. So 10 to the second is the same thing as 100. 10 to the fourth is the same thing as 10,000. No, we're not using commas. 10 to the seventh, okay, would be, all right, 1, 2, 3, 4, 5, 6, 7 zeros. Okay, 10 to the negative 2 would be 0.01. 10 to the negative 5, okay, would be 0.00001. And 10 to the 0 is 1. Okay, let's look at some other problems. What if we had 3.0 times 10 to the second? This would be the same thing as 300. What if we had 7.0 times 10 to the fourth? This would be the same as 70,000. What if we had 2.4 times 10 to the third? This would be the same thing as 2,400. So how would this work? So you have the 2.4, so you would go 1, 2, 3. And then, of course, you can see your 2,400 right there. All right, let's do another one. Let's try this one. Let's try 6.3 or 6.0 times 10 to the negative 3. So if you had 6.0, you went negative 3, you go 1, 2, 3 in this direction. You add zeros, it'd be 0.0060, or you could put 0.0060. Either way, it's still the same thing. All right, let's try another one. Let's try 900 times 10 to the negative 2. Okay, first of all, you would never write it as 900 because you always have to have a decimal point. So you would have to put a decimal point here on the end. So you would go 900 to the negative 2, go 1, 2, which would give you 9.00. Okay, let's try another one. 4 times 10, 4, whoops, let's not do that because remember, that's not a good thing. We need to put 4.0 times 10 to the negative 6. So you would write 4.0 here, then you go 1, 2, 3, 4, 5, 6. And when you make a new decimal, put all the zeros in there. So that would give you 5 zeros in the 4. So it's equal 0.00000. There's my 5 zeros. There's my 4. What about that 0 in the end? Yeah, you could leave it there, or you could just simply write it as 0.00004. Either way, it's the same thing. Okay. So guys, let's look at another way. So if you wanted to know the exponent power, let's say you had 10, that would be the same thing as 10 to the first. If you had 100, that would equal 10 to the second. Okay, and then if you had 1,000,000,000,000, this would be 10 to the ninth. Okay. If you had 0.1, that would be 10 to the negative 1, because we're going the opposite direction. If we had 0.0001, that would be 10 to the negative 4. And of course, 1 is always equal to 10 to the 0 power. Okay, so let's look at a couple more problems. Let's see here, let's clear all my drawings. Let's say you had 400. You would want to put a decimal point on the end. So then you would go 1, 2, and that would be 4.0 times 10 to the second. Let's say you had 60,000. Then you would put a decimal right here. You go 1, 2, 3, 4. It would be 6.0 times 10 to the fourth. Let's say you had 750,000. Okay, then you go put a decimal there, 1, 2, 3, 4, 5. That would be 7.5 times 10 to the fifth. What if you had 0.005? You're going to move the decimal over 3 places. 1, 2, 3. That'd be 5.0 times 10 to the negative 3. What if you had 0.0034? You go 1, 2, 3. Move the decimal there. That'd be 3.4 times 10 to the negative third. And last but not least, what if you had 0.06457? Well, you're going to go 1, 2, 6.457 times 10 to the negative 2. Remember, when you write the scientific notation, you always have to have one number to the left of decimal, and you can have as many numbers as you want to the right. Well, listen, sorry about that. That should be 10 to the first. So listen, guys, you have a snarly day, and we'll see you back here at Moose in Chemistry.